Let's look at Fourier transform in vibration. So, so far we had a system. So we have some system, and we had K, C, M, and we have forcing f of t for for a harmonic. So this can be split into harmonic. We see the response. Plus 1 by 1 minus r square whole square plus 2 neta r whole square. So f naught by k. So therefore this is xst e power whatever that harmonic. So this is the equation, and then we see the step from unit step function. So unit step function for the g of t. So we have seen g of t, then we see impulse function. So impulse, which is Kronecker delta. So we have seen h of t. This is unit impulse function. H of t will be, so what is that, 1 by m omega d. So sine of omega dt minus theta. Then we have seen for arbitrary wave. So arbitrary wave, what will be the, so arbitrary function. So what will be the x of t? So x of t will be e power minus neta omega t, which is homogeneous part of solution, plus that convolution integral, so which is minus 0 to infinity, so which will be f of tau into h of t minus tau into d tau. So this part is called convolution. So we can we can write this f of t convolution of h of t, and this is commutative, h of t convolution f of t. Then we have seen this arbitrary function. We can, this is one way of doing it. The other way of doing is through Fourier series. So where any f of function will be represented as Fourier series. This is, here t is time period, sine 2 pi n by t into t. So this is one form of Fourier series. There is another form, will be the exponential, complex exponential form, and I will write the direct formula for this, so you can refer this crazy mathematics book. So where that f of m will be, this f of t will be summation n is equal to minus infinity to plus infinity cn e power I n pi t by L. So here L will be time period t, and here it will be 2 pi. So same will be 2 pi by t into n times of t. So t is time period, and where this cn will be 1 by time period of minus t by 2 t by 2 f of t exponential of minus I into 2 pi by time period n into t into dt. So this one is very important. So this will be useful to reduce the complexity of equation. So you must know these are two different form of Fourier transform. So now we will see Fourier series. Sorry. So now we will see Fourier transform. So what this Fourier transform? This Fourier transform will transform from one domain to another domain. So let's say you have x of t. So I will write definition. Definition. So let's say you have x of t. You have x of t is the response of the function, but you want to, this is time domain. So you want to convert this signal into Fourier frequency domain. So to convert into, it will be x of omega frequency domain. What will helps is the Fourier transform. So from here to frequency domain to the time domain, some other thing will be used, that is inverse Fourier transform. Fourier transform F inverse, it is called F inverse. So this one is called F. So now we will see the definition. The definition, x of omega equal to integral 1 divided by 2 pi minus infinity to plus infinity x of t e power minus I omega t dt. So there won't be 1 by 2 pi. So this is Fourier transform. So inverse Fourier transform will be x of t will be 1 divided by 2 pi minus infinity to infinity x of omega e power I omega t dt. So now if you substitute this, yeah, you will get this. So this is inverse Fourier transform definition.